Welcome back to Talking Business as Usual. Today, we are diving deep into one of the biggest pivots in technology. Maybe ever. We're talking about the shift from AI that can just think to AI that can actually do. This is the dawn of physical AI, and it's a change so fundamental that we're calling it the agentic shift. And let me be perfectly clear right up front. This is not a special edition. This isn't some far-off sci-fi concept we're dreaming about for the year 2030. No, this is happening right now. The conversations are changing in boardrooms, the planning is changing on factory floors, and in this explainer, we're going to break down exactly what's going on. So let's just start with this one massive question. For the last couple of years, we've seen AI generate incredible things, right? Text, images, code, all from a prompt. But what happens when that intelligence breaks out of the screen? What if it could not just write about the world, but actually perceive it, reason about it, and physically interact with it? That single question is the engine driving this entire revolution. So to really get our arms around this, here's what we're going to cover. First, we'll nail down what this agentic shift actually is. Then, we're going to pop the hood and look at the new hardware that's making it all possible. After that, we'll map out the new economy that's taken shape, point to the likely winners and losers, and finally, we'll give you a framework for how to think about all this from an investment angle. All right, let's dive right in. Section 1, the agentic shift is here. And this isn't just a simple software update. We're talking about a fundamental change in AI's job description, moving from making digital stuff to taking physical action. So what is physical AI really? Well, you can think of it as the bridge between the digital world and our physical one. You know those old factory robots? They just blindly repeat one task over and over? That's not this. Physical AI systems can see, they can understand their surroundings, they learn as they go, and they make smart decisions on the fly. This slide really just nails the difference. Generative AI, the thing we've all been talking about, is all about predicting the next word or the next pixel. It lives online. But agentic AI, it's about deciding the next physical action. It lives in our warehouses, on our highways, in our hospitals. It's the difference between an AI writing a report about low inventory and an AI actually picking up a box and stocking the shelf. And look, if you think this is all just theory, it's not. Just look at the hard evidence from this year's Consumer Electronics Show. We saw actual humanoid robots from Hyundai and Boston Dynamics designed for logistics. Mercedes showed off cars where the AI makes driving decisions right there in the vehicle. We saw new laptops from Qualcomm built to run AI tasks locally without the cloud. And even Caterpillar was there with autonomous construction machines. It's here. So that brings us to a super important question. If these machines can think and act, what's actually powering them? In this next section, we're going to get into the anatomy of this new hardware. Okay, this is probably the most critical concept for understanding the hardware story, and this brain versus spine metaphor is the perfect way to think about it. For the last few years, all the hype, all the money, it's been about the brain, the super powerful GPUs from companies like NVDA that you need to train these giant AI models. But for an AI to actually act in the real world, safely, logically, it needs a spine. It needs a system for step-by-step logic, for safety checks, and that's the world of CPUs and specialized chips from guys like AMD, Intel, and Qualcomm. The GPU-only narrative, it's over. And a key part of that spine is something called Edge AI. Think about it. A robot or a self-driving car can't afford to send data to a server in Virginia and wait for instructions. That latency would be disastrous. Decisions have to happen in milliseconds. Edge AI just means that thinking happens right on the device itself, which is absolutely essential for speed, for reliability, and for keeping power consumption down. So how do you actually build one of these things? Well, it's this fascinating dance between the cloud and the edge. You start in the cloud, using massive supercomputers to train the huge foundation model. Then, and this is cool, you test it out safely in a simulation, a digital twin of the real world, so it can fail without breaking anything. Once it's ready, you deploy a smaller, more efficient version of that model onto the robot's onboard chip. But here's the real magic. You create this feedback loop, where data from the robot's real-world experience is constantly sent back to the cloud to make the original model even smarter. It's a nonstop cycle of improvement. Now, a whole new workflow like that, well, it creates a whole new economy. So in Section 3, let's start mapping out who the key players are, what the business models look like, and get a sense of just how big this opportunity really is. And the scale we're talking about is just staggering. We're not talking about billions here. Sources like ARM are openly calling this a multi-trillion-dollar opportunity.
This isn't just a new product. It's a fundamental rewiring of major industries, from logistics to manufacturing to mobility. So who's getting a piece of this giant pie? Well, it's a whole ecosystem. You've got the chip designers at the very core, the ARMs, the Qualcomms. Then you have platform integrators like Siemens building the industrial operating systems. Then you have the massive adopters. Think Amazon, Tesla, deploying these things by the thousands. Of course, you have the actual robot makers themselves, like Boston Dynamics. And finally, the software players, providing those virtual training grounds. Out of that ecosystem, we're already seeing three main business models emerge. First, you've got the arms dealers. These are the companies selling the picks and shovels to everyone else in the gold rush. Second is what we're calling the hoarder strategy, which Amazon has perfected. They use robots to let their business grow without having to hire more people, decoupling growth from headcount. And third is robot as a service, or RaaS, where you can hire a fleet of robots on demand, which is a direct threat to the traditional temp agency business. Now, anytime you have a shift this big, it creates a ton of disruption. So for our fourth section, let's get real and take a hard look at the winners, the losers, and the very real risks that are on the road ahead. Yeah, the battle lines are being drawn pretty clearly. On the winning side, you have the companies making the core tech and the companies that can use that tech to bring manufacturing back home. On the other side, well, industries built on armies of temporary human labor, like temp agencies, are at risk. So are nations whose main economic advantage is cheap labor. And even old-school robot makers who can't adapt to these new AI-driven systems could get left behind. And this isn't happening overnight, but the timeline is definitely speeding up. This year, we're seeing the early adopters really start to scale. Next year, we think, is when the market's focus really snaps to that new spine hardware. By 2028, we expect to see physical AI moving way beyond the warehouse into places like healthcare and construction. And by 2035, some forecasts are calling for over 1 billion AI-powered robots. But it's not a done deal. There are some major hurdles. Battery life, what we're calling the 2-hour energy wall, is a huge one. Then there's the whole liability mess. Who's at fault when an autonomous machine messes up? We're also seeing robots struggle in what's called the brownfield trap. They work great in a brand new, pristine factory, but not so well in older, messier ones. And, of course, connecting all these physical machines to a network opens up a whole new world of cybersecurity risks. And all of that brings us to our final section. With all this context, the tech, the players, the risks, how can we put together a strategic framework to really understand this revolution from an investment point of view? So let's just ask the question straight up. How should we be thinking about investing in physical AI? Because it's definitely not as simple as just picking one robot company and hoping for the best. It's really about understanding the fundamental hardware shift that's happening underneath everything. And this brings us right back to where we started, our brain versus spine framework. For the last 2 years, the obvious play, the brain trade, was all about the GPUs needed for training. That trade is now really well known, maybe even a little crowded. The next chapter, the emerging opportunity, is what we're calling the spine trade. This is the catch-up trade. It's focused on the CPUs and the edge chips that are absolutely critical for action, for safety, for orchestration. This is where the agentic shift is forcing the market to look next. Now, of course, we have to say it. This is all for informational purposes. It is not financial advice. Please always, always do your own due diligence before making any kind of investment decision. So, we'll leave you with one final question to think about. In your own daily life, where do you think you'll see physical AI first? Is it going to be a delivery drone dropping a package on your porch? A robotaxi picking you up? Or maybe something none of us have even thought of yet? The agentic shift is here, and it's about to get very real. Thanks for tuning in to Talking Business as Usual.